Hi guys, welcome to another episode of Learn Technology in 5 Minutes by MakerDemi. This is Naveen and I am part of the instructor team at MakerDemi. We have already covered several key concepts of MQTT on the Learn Technology in 5 Minute video series. So in this episode, we will take a look at a lesser known variant of MQTT called MQTT-SN. MQTT-SN is also called as MQ Telemetry Transport for Sensor Networks. MQTT is already a highly optimized and lightweight protocol that consumes a very small amount of power and bandwidth. Then why should MQTT-SN exist at all? To answer that question, we need to talk about money. More specifically, the cost of operation of large wireless IoT networks that run on MQTT. In most of the videos or lectures on the internet, people portray an MQTT system in a very simple way. In real life, there may be thousands or even millions of wireless IoT clients interacting with a broker. Many IoT projects fail due to unpredictable operation costs because of large amounts of data being produced and transmitted. On top of this, a combination of factors like power costs and costs of unreliable data together can make the MQTT network costs spiral out of control. Thus, the system won't be able to scale beyond a point. This will further compound the effects of the growing complexity and fragmentation of the IoT ecosystem. Thus, MQTT was modified further to reduce power consumption, reduce payload size, and also to add a standby feature to form the MQTT-SN. It is very similar to MQTT in its communication approach, but it is tailored to avoid the potential problems that occur due to scaling. It uses the same publish-subscribe model as MQTT. The major differences involve reducing the message payload size and using UDP as the transport protocol instead of TCP. The transport protocol change meant that there was no need for a permanent connection. Now let us look at the architecture of an MQTT-SN system. It consists of 4 components: clients, broker, MQTT-SN gateway, MQTT-SN forwarder. We already know what a client and a broker is. Now let us first look at the MQTT-SN gateway. It is a translation layer that converts MQTT packets to MQTT-SN packets and vice versa. It can be a separate entity or be the part of the broker itself. There are 2 types of gateways. A transparent MQTT-SN gateway involves only translation. Thus, the broker has to maintain concurrent MQTT connections, which can get tough if we are dealing with an enterprise level system. The second type of MQTT-SN gateway is called as an aggregating gateway. As its name suggests, this gateway is responsible not only for translation but for the collection, filtering, and processing of client messages. There is only one connection between the aggregating gateway and the MQTT broker. This approach is good for the servers that do not support a great number of concurrent connections. But also, this variant is more difficult to implement. Now let us take a look at MQTT-SN forwarder. A forwarder is used when the clients cannot directly communicate to the MQTT-SN gateway. This can happen if the gateway is not directly attached to the same network. The forwarder simply encapsulates the MQTT-SN frames it receives on the wireless network side and forwards them unchanged to the gateway. In the opposite direction, it releases the frames it receives from the gateway and sends them to the clients unchanged. Now we have looked at a brief overview of MQTT-SN and its architecture. That is all folks. If you like this video, smash the subscribe button and ring the bell to be updated about our future video releases.